The test will begin in 4 seconds. In the past, and as incredible as it may seem, it was believed that in a car accident it was better for you and the other occupants to be thrown out of the vehicle rather than being restrained or held by some kind of device made for that purpose. That's because anything that held a person tightly during a collision could cause them serious internal injuries. Besides that, cars at the time were built with a 100% focus on mechanics and the proper functioning of the vehicle and its parts, completely neglecting the safety of their occupants. So the shape, the design, the material of the chassis, the interior of the vehicles, and so on, were all designed with the vehicle's performance and the comfort of its occupants in mind. But the fatality rates in accidents kept increasing, as the charts show, with the peak being reached in 1972. Just 3 years earlier, seat belts had become mandatory.
Em todos os novos veículos.
Only 26 years later would airbags become mandatory in all new vehicles. So during accidents, cars from that time would crumple halfway, in some cases even more, break in half or get completely crushed, taking with them whoever was inside. And it was to change this catastrophic scenario that accidents started to be deeply studied, with several organizations being created specifically to study and analyze so that the dynamics of these events could be better understood, some of them being the NHTSA, Latin NCAP, and Euro NCAP. An old car was not equipped with seat belts, airbags, crumple zones, or survival cells, glass designed to shatter safely, ABS system, side airbags, electronic stability control, among others. All of this was introduced as a result of what was learned during the studies of accident dynamics. Most of these items are now mandatory in any modern car coming off an assembly line. But let's understand how the tests are done. The tests conducted by these organizations, specifically Latin NCAP and Aero NCAP, are based on 4 main aspects: adult occupant protection, child occupant protection, protection of pedestrians and vulnerable road users, and safety assistance. In the adult occupant protection test, 6 different types of tests are conducted: the frontal impact, the side impact, the pole side impact, autonomous emergency braking, whiplash, and the rescue sheet. All of these are tests focused on the safety of the 2 people in the front of the car, that is, the driver and the passenger. The frontal impact is a test done with the vehicle moving at 64 kilometers per hour and crashing head-on into an offset deformable barrier. This test aims to recreate the most common type of collisions on roads that result in serious or fatal injuries. With the readings obtained from the dummies, which are these test mannequins, they are used to assess the protection provided to adult passengers traveling in the front. The impact is intended to recreate a collision between 2 vehicles of similar mass, with each one moving at 55 kilometers per hour. In addition, only 40% of the front part of the vehicle comes into contact with the deformable barrier. That's because in a real accident, usually one of the vehicles manages to partially swerve, causing the collision to occur in about 40% to 50% of the front part of the vehicles. And at 64 kilometers per hour, because a large portion of accidents happen with vehicles at speeds close to that. Even in accidents at higher speeds, like 100 kilometers or 120 kilometers per hour, one of the vehicles is always able to partially swerve away from the other, getting closer to that speed. In the test, 2 adult dummies are placed, representing average-sized men in the driver's seat and the passenger seat, and 2 child dummies, 18 months and 3 years old, in child restraint seats in the back seat. Several parameters are analyzed and taken into account to classify and determine whether the vehicle passed the test or not. such as the correct deployment of the airbag, the size of the airbag, and whether the dummies make proper contact with the airbag, since several tests have already shown serious failures in this regard. How and by how much the car's chassis structure deforms, and whether the interior, specifically whether the driver's dashboard comes loose or detaches from where it's mounted. If there is any sign of smoke or fire after the collision, if the seat belts work properly, if the dummies hit the window pillars or other solid parts inside, if the dummies in general are thrown during the collision, and hundreds of other parameters. It's quite a test, and several vehicles have already failed and continue to fail it, including many recent cars that fail at some point in the test. Whether it's because the car deformed too much to the point of putting one of the occupants at risk, or for other reasons, such as a failure in some safety system. The other test is the side impact test. In this test, a deformable barrier mounted on a cart is propelled at 50 km/h until it impacts the stationary test vehicle at a right angle. Inside the vehicle, a side impact dummy is placed, representing an average-sized man in the driver's or passenger seat, and two child dummies in child restraint seats in the back seat. This test aims to study the effects of side impacts, which are the second leading cause of death and serious injury, compared to frontal impacts. There is very little space inside the vehicle to absorb this side impact energy, and as a result, serious head and chest injuries are common. Many modern vehicles already come with side airbags for the head area and the side of the torso, which already significantly reduce the extent of these injuries. The third test is the side impact test. In this test, the vehicle is launched sideways at 29 km/h towards a rigid and narrow pole. The vehicle is positioned at a right angle to the direction of movement, or at a slight angle away from perpendicular. A medium-sized male side impact dummy is placed in the driver's or passenger's seat. These accidents are severe, and the frequency of deaths or serious injuries is very high. This is a very severe test, which assesses the vehicle's ability to protect the driver's and passengers' heads in side impacts. Since the load on the vehicle is highly concentrated, the deformation can be quite pronounced and the pole can penetrate deeply into the passenger compartment, causing serious injuries or death. Protective airbags, such as curtain and thorax airbags, have become a common solution, but their design and implementation must be very precise to ensure effective performance. There is also the autonomous emergency braking test, where AEB systems, or autonomous emergency braking, are tested, which uses a forward-facing radar, cameras or optical sensors, or a combination of these to quickly and properly detect vehicles, pedestrians, or other potential obstacles. This information can be used to alert the driver and apply the brakes, and even slow the vehicle down. It's an effort to avoid and mitigate collisions. The AEB system helps provide constant monitoring of the road ahead and is designed to assist the driver by automatically activating the brakes if they don't do so in time to avoid an imminent collision. When the system is very well designed and works properly, it actually prevents fatal runovers and can also prevent collisions with other obstacles. The seat is also tested, specifically the backrests and headrests, in a test known as whiplash. A test that aims to analyze, study, and mitigate injuries caused to the spine and neck in situations of sudden acceleration, such as those that happen in rear-end collisions. And finally, the vehicle's rescue sheet is analyzed, which is precisely the diagram that clearly and concisely shows rescue teams where and how different sections of the vehicle should be cut to access the victims in case of accidents. Certain parts of the vehicle that were not designed to be cut can greatly delay the rescue and may even damage the rescuer's cutting tools. That's why this sheet is extremely important and must be properly laid out according to the ISO standards that are known worldwide. The next category is child passenger protection. in which the dynamic behavior of the CRS or child restraint system is evaluated. In the frontal and side tests, the car's ability to accommodate a range of child restraint systems correctly and without any issues. The other category is pedestrian and vulnerable road user protection. In this category, the maximum level of injuries that a vehicle can cause in the event of a pedestrian collision is tested and studied. Basically, they test and study how the front part of the vehicle behaves and deforms when hitting someone, who could be an adult or a child. The front part of the vehicle cannot be too rigid or undeformable, so as not to cause serious injuries. And finally, there is the category of safety assistance systems, which includes 7 tests: the seatbelt reminder, the electronic stability control test, plus a user test, with this being the last one, a test in which many vehicles have often failed. The blind spot detection test, lane support system, road edge detection, speed limiter, and finally, the high-speed autonomous emergency braking test. Let's move on to some controversial points. Strangely enough, it's not mandatory for companies to send their cars to be tested. A list is made with the best-selling cars and their sales volume. From this list, the cars to be tested are chosen, meaning the cars with the highest sales volume are the ones that get tested. Cars that are of particular interest or relevant to a specific market can also be tested, although companies can voluntarily send their new models to be tested. That's because in many countries there isn't a law that requires manufacturers to send their cars to be tested. And it's practically impossible for these organizations to test all the new models that come onto the market. So the tests are fully funded by the partners of these organizations. But in principle, all new vehicle models must be submitted to these tests in order to prove whether they are safe and meet the current safety requirements. The test rating ranges from 0 to 5 stars. 0 stars means there is a risk of an occupant suffering life-threatening injuries, and 5 stars are those in which the occupants have a high chance of not suffering serious or permanent injuries. In principle, 4 cars are needed for the tests, of which at least 3 will be destroyed. And things get complicated when it comes to luxury models or supercars, with the final price of the model possibly being over $1 million. But for this type of car, the protocols are different. That's why it's not very common to see this kind of testing being done with every new model from Ferrari, Pagani, or Koenigsegg. In these cases, most of the time, the companies have their own testing programs carried out in controlled in-house environments. Or the model can be destroyed in highly reliable 3D simulations. So, a safe car can't have its structure made of hard, non-deformable materials, nor can it have its structure made of materials that deform too much. So the ideal car is somewhere between these two worlds, not too deformable but not completely rigid either. That's why it's not a good idea to get hit by a Cybertruck or an armored cash transport vehicle. The airbag doesn't replace the seatbelt, just like the seatbelt doesn't replace the airbag. Both need to work together to reduce the chances of serious injuries or fatalities in the event of an accident. Wearing a seatbelt helps keep you safe and secure inside the car. Not wearing a seatbelt can cause ejection from the vehicle during an accident, which often results in fatalities. Airbags alone are not enough to keep us safe. In fact, the force of an airbag can cause serious injuries and even death if you're not wearing a seatbelt. But even with all these safety measures used in cars, like a structure designed to deform while absorbing impact energy, seatbelts, airbags, and others, a modern car can still fail miserably and leave its occupants completely unprotected in the event of an accident. If that accident happens when the car hits the back of a truck, that's because the car can end up sliding under the truck, collapsing the passenger cabin. That's why trucks have that structure on the rear and sides to prevent this kind of accident. With all that said, now just think about how hard it is to build a modern car. It has to look good inside and out, be aerodynamic, use little fuel, and be deformable, so that the vehicle's structure absorbs most of the impact energy. And, at the same time, to reduce the severity of injuries to pedestrians if they're hit by a car, have a stronger side structure for side impacts, and at the same time have parts of the structure designed to be cut in case of accidents. Yeah, it's not easy. And which are the best cars? Well, there are many.
Das mais diversas marcas,